Okay, so we're on implicit differentiation, part 1. Okay, and here we're going to be dealing with, now you have to remember when we do this, that we're dealing with y as a function of x, all right? So when I take the derivative of y, it's going to be a chain rule kind of thing. So let's talk about then, instead of me going through and telling you, I think the best way to learn this is to actually go through and work some example problems. So let's take a look at a problem which looks like this: x squared plus y squared equals 36. And we want to find dy dx. Okay, well, you notice I've got a y squared here. Okay, and so this is where the chain rule is going to come in. But first, let's do this. So we do x squared. Well, that's easy. That's power rule. So I've got 2x. All right, so in here, the first thing we do then is let's differentiate this. So it would be plus 2y. And then the chain rule means I need to also differentiate the stuff inside of there. And that would be dy dx. And this is going to be pretty typical. Anytime you've got y as a function of x, you're going to do the derivative of the big guy, and then you're going to tack a dy dx on the end of it. And now we take the derivative of a constant, which is 0. So to find dy dx now, this is just a simple algebraic way of doing it. You solve for it. So we subtract 2x over, so 2y dy dx equals negative 2x. Then I divide by 2y. You notice the 2's cancel out, so it's going to be negative x over y is my derivative. And that's my derivative of what we had before. Okay. Let's look at another example then. Sine of x plus 2 cosine of 2y equals 1. Okay, and this one's kind of nasty because I've got a chain rule inside of a chain rule. So the first thing I'm going to do then is come back in and take a derivative. Now remember, with y we're going to have to do a dy dx. So when I do this, the derivative of sine of x is cosine of x plus 2 times. Okay, so now we take the derivative of this guy, which is a negative. Derivative of cosine is negative. So minus 2 and it will be sine of 2y. And then I take the derivative of what's inside of here, which will be 2 times dy dx equals, and the derivative of 1 is c. Okay, so first thing I'm going to do is start combining all of this mess, clean it up. So 2 times 2y gives me 4y. Excuse me, 2 times 2 gives me 4. Okay, then I've got sine of 2y times dy dx equals 0. Okay, so now we solve for dy dx. I'll move my cosine of x over. We want to have negative 4 sine of 2y dy dx equals negative cosine of x. And I'm going to divide by my minus 4 sine of x, or my 4 sine of 2y. So give me dy dx equals a negative divided by a negative is a positive. So I'm going to have cosine of x over 4 sine of 2y. And there's your derivative. Okay. Let's work through another example. This one gets even a little more complicated. X cubed, y cubed, minus y equals x. Product rule. It's back. Okay, so let's do my product rule first. F is x cubed. G is y cubed. F prime is 3x squared. G prime will be 3y squared times dy dx. Okay, and then to get that, then we just cross multiply. So I'm going to have 3x squared y to the cube plus 3x cubed y squared dy dx. So that just gets me this term right here. Minus, I take the derivative of this, which is dy dx equals, the derivative of x is 1. Okay, so the next thing you're going to do then, find my cursor, is collect all the terms with the dy dx, leave them on this side, move everything else over. So I'm going to move this over. So you're going to have 3x cubed y squared dy dx minus dy dx equals 1 minus 3x squared y cubed. Okay. So initial thinking is, ooh, those cancel out. No, because this guy is multiplied by here. So what you want to do is factor out your dy dx. I factored out, I'm left with this over here, 3x cubed y squared minus 1 equals 1 minus 3x squared y cubed. Okay, so now to get this, I divide by this stuff right here. So my dy dx will equal to 1 minus 3x squared y cubed over 3x cubed. And there's your derivative. So remember, the trick here is to factor your dy dx out when it's in more than one term. And then divide by what's over there. You move it over here, and you got your derivative.